If x is a positive integer, what is the remainder when 3 to the power x plus 1 is divided by 10? Okay, every time you divide a number by 10, the remainder is always going to be the units digit. Now, for example, if I divide 23 by 10, the remainder is 3. If I divide 78 by 10, the remainder is 8. Okay, so what they're really asking us here is, what is the units digit of 3 to the power x plus 1? Now, statement 1 says that x is 4n plus 2, where n is a positive integer. And the powers of 3, the units digit of the powers of 3, repeat every 4 integers. Why? Because if you have 3 to the power 1, this ends in 3. 3 to the power 2 ends in 9. 3 to the power 3 ends in 7. 3 to the power 4 ends in 1. 3 to the power 5 ends in 3. And we are starting to repeat. No, 3 to the power 6, 9, 3 to the power 7 ends in 7. 3 to the power 8 ends in 1, and so on. It's always going to be 3971, 3971. So if they tell us that x is 4 times n plus 2, it's a multiple of 4 plus 2. It's no coincidence that multiple of 4 is the same number at which every unit digit repeats. So the first value would be 6. That is, it ends in 9. Plus 1, it ends in 0. So you have an answer. The remainder would be 0. The next one would be 8 plus 2, 10. So 3 to the power 9, 3 to the power 10. This would be 3. This would be 9 again. So the remainder is 0. And so it's always going to be 9, right? Because if I add another 4, then it would go to 14, and that would also end in 9. So statement number 1 is sufficient because it always gives you a unique answer, which is 0. It ends in 0 when you add 1. Now, statement number 2 says that x is less than 10, but x less than 10 could be any one of these remainders, right? Well, units digit. It could be 3, 9, 7, 1, and plus 1, it would be 4, 0, 8, or 2. So you have many answers for the question. Therefore, statement 1 alone is sufficient. That is A.